Yes, I'm around.
Okay, thank you very much for being around. Prof. Majaliwa will talk about the technical details of this engagement, but I'll use this opportunity to welcome all of you and all of colleagues from the RUFORA member universities who are joining this training of trainers. We are calling it a training of trainers because we anticipate that it will then seep into our different universities so that we promote how it is offered. It is not very restricted at this point in time because you will customize it based on your requirements at the member universities. Let me just give a brief background. RUFORAM is a partner with several other like-minded agencies, but particularly the CGIAR centers in promoting climate smart agriculture. This program is an ACRA World Bank funded program that is a 4-year program that is looking at how we can promote climate smart agriculture and climate information systems. RUFORAM was tasked with the need to promote climate smart agriculture and climate information systems in our respective universities and what they call next users. So this segment of it is how do we promote climate smart agriculture and climate information systems within the university network. We at RUFORAM, together with some member universities, came up with 8 modules, and Professor Majaliwa will talk a little bit more about this. This is being one of them. And they're going into a series of engagements. First, we had a scoping to establish which modules are more needed under climate smart agriculture. And then from there, we went into the development of the modules. And from the development of the modules, now we are having this as a pilot. So the learnings that we get from this training today, which will inform the other training of trainers that are going to be undertaking. But for now, this is what we have. And I want to thank Professor Zelalem for agreeing to be the guinea pig as far as this training of trainers is concerned. Feel free to ask any questions, and we are open to engage you further in case you need additional information, either for how the TOT is going to run or for the subsequent training of trainers that we are going to have. I know David will share these ones later, and maybe Prof. Majaliwa can talk about them as well. But for now, to welcome you so that I don't spend a lot of time into talking, when actually what you have come for is the real thing, the meat of it. And I see that Prof. Zelalem is really...
No.
Okay, how it is working, and the bulk of it, the soil. I know we can't do anything without the soil. So let's start from the soil, even as we go into the other modules that are going to be considered under this partnership for the ACRA program. Thank you very much. I wish to welcome you all. RUFORAM, as David was saying, is a network of 163 universities now in 40 countries, and each university will adopt and adapt depending on what works best for them. Thank you very much for joining us. Over to you. I think, let me give this opportunity briefly to Professor Majaliwa to say something about the modules and the modus operandi, even as we get into Zelalem, giving us the details of it. Thank you very much. Professor.
Thank you, Dr. Florence. Good morning and good afternoon, depending on where you are. Thank you for attending this trainers course, which Zelalem is going to offer for the next 4 days. As Dr. Florence said, we are developing 8 modules on climate smart agriculture and climate information system. We also have from the principles to the policy. So we have for this particular one is on nutrient and water management, but we also have introduction to climate smart agriculture and climate information system. We also have for energy, agroforestry, crop and livestock interaction. We have policy, as I say, we have soil and water conservation, but we also have the general climate variability and risk modules. So this module of today, the nutrient and water management, has been packed in seven sessions. The first session is basically the introduction and the principles, and then we go into challenges of climate change to soil and soil fertility management. But soil fertility management can be done at plot level, but also Zelalem has integrated the landscape approach in this course. And then you have nutrient management for climate adaptation. And in the climate, the nutrient management, we also talk about the concept of nutrient management, but we also have water management and then soil and water interaction. So this is a full package, and I hope everyone will be happy with it. We'll be happy also to welcome your comments on the module so that we can be able to improve this module for the next training. So those are the few technical aspects I think I could say for the moment. I will ask, therefore, David to take over and possibly allow Zelalem to start with the module training.
Thank you, Prof. Majaliwa and Dr. Nakaiwa, for ushering us into this session. Just to let participants know that we do have French translation. So if you're comfortable with, you're not comfortable with English, you can tune into the French translation and follow the training. Otherwise, I think at this point, let me hand over to Professor Zelalem to introduce himself and as well as the module and take us through. Thank you very much.
Thank you, David, Prof. Majaliwa, and Dr. Florence. Yeah, I'm very glad to say good afternoon and good morning to all of you all over African continent, from Eastern, Western, Southern, and Northern African regions. And I would like to thank RUFORUM for connecting us on this platform. My talk for the next 4 days will be revolving, as Prof. Majaliwa indicated, on soil, nutrient management, and water for crop production in the context of climate change, basically from experience of African countries. So my name is Zelalem Bakako, an associate professor at Haramaya University and the Dean, College of Agriculture and Environmental Science at Haramaya. Welcome everybody to this training, and I will continue my training through sharing my slides to you. Yeah, as indicated by Prof. Majaliwa and Dr. Florence, this process is supported by ICRAS through the reform, and the module is developed for all African universities for African agriculturalists. So to start with my talk is divided into 7 sections. I'll be talking on the bird's eye view of the background and justification of the module. And in the second section, I will talk about soil-plant-water interaction. And thirdly, I'll see the challenges of climate change on soils and soil fertility management. And section 4 includes the landscape approach for achieving crop production on sustainable ways. And section 5, we will see the interaction of nutrient management for climate adaptation for crop production and water management for crop production. And finally, we integrate crop and water management system for sustainable crop production in the realm of climate change. So at the end of this training, we'll be having at least 5 outcomes. On the first one, it will be expected that the trainers will be able to identify, demonstrate, and see the effect of climate change on soil and soil fertility management. And the second outcome will be the trainers will be demonstrating the issues of landscape management from plot level to the landscape, including climate smart agriculture through nutrient management. And the third outcome will be trainers be demonstrating apply concepts, principles of soil health for crop production. And on the fourth outcome, the trainers will be demonstrating the concepts and the principles of water management for crop production. And finally, we will be having the interaction of nutrient and water management for sustainable crop production. To start my talk, as background and justification of the module, as we all know, the world population is now increasing from time to time. For example, if we refer to the World Bank document of 2020, we are currently facing food production because of various calamities. And the trend of global world population and global crop production is now in disparity. And we are so facing loss of natural resource degradation, including water, soil, biodiversity, and this directly influences crop production and livestock production all over the globe. For example, if you consider the one aspect of crop production, this crop production, basically cereal production all over the world, including Africa, most of the production system is currently influenced by the climate change. As we all know, 80% of global food supply is from the cereals, and this climate change is seriously influencing cereal production. If we see the trends of population, by the way, are you following me, please? Am I faster?
We're with you.
I'm faster, or is it okay?
Please, let's.
You are okay. You are okay.
Yes,
It's okay.
you're
It's
okay,
okay.
please. Go ahead.
Thank you very much. Now, if we see this trend from this curve, this is an analysis, a trend analysis done by the World Bank 2022, population versus cereal production trend analysis. As we see from 2000 to 2021, for the last 21 or almost 22 years, the global population is increasing. The global grain demand is also increasing, but the global grain production is paradoxically declining or decreasing. This tremendously influences food supply through the value chains to the world population. And it will be worsened in 2013, even in 2015, when the population will be booming from 8 billion to 9 billion in 2050. So the currently existing agricultural practices doesn't support this grain production to supply the global food demand, especially in Africa and Southeast Asian countries. So we have to intervene the way agricultural practices are demonstrated through crop production and livestock production in attaining or in ensuring trends of food security and food demand. We can easily see this trend for Eastern African region with the green line, for South African nations, Sub-Saharan, with the black on red spots, and the world population with red on black spots. So this trend clearly showed how grain deficit will be appearing in the next years, and the necessary steps that we have to follow in order to supply our population with appropriate food demand. So in this connection, population pressure is one. On this pressure, the so-called climate change is now emerging and realized in Africa, especially in tropical Africa, basically in sub-Saharan African regions. This can be manifested through rainfall pattern shift, through patterns of heat waves, through recurrent droughts, extreme water deficit in field level, and the shrinking of dams. Some literature supports this view, especially Niger et al. Reported in 2014 that climate change is now realized, and we have to get ready to tackle this evil so as to sustain the human population survival. Basically, this climate change is directly influencing the availability of food, food production, agricultural productivity, especially in sub-Saharan African countries and Southeastern Asians, and is challenging the way our economy is evolving and booming and in sustaining our livelihood. The major impact of this climate change is really can be demonstrated or can be seen in the reduction of yields at field level, in increased yield variability at plot yield landscape level, and in displacement of crop diversity, livestock breeds, and agricultural biodiversity, which we literally call genetic erosion. This climate change typically causes genetic erosion in reducing the type of crop we produce and the type of livestock patterns that we follow. And it directly influences the growth of economic development of every nation. So this climate change on farm level reduces yield and the nutritional quality of cereals and reducing the productivity of livestock sector. So this is a very tough case. So if we see the major cereals and the grains produced in Africa, almost we can say African crops like cassava, yam, groundnut, millet, rice, sorghum, and maize. And if we see over centuries using climate models, especially for Africa, from 1950 to 2021, for almost closer to a century, the trend shows this climate change will be adversely influencing the production and the productivity of these African crops. So this directly influences our survival through influencing availability of food for income, for nutrition, and for economic development. So this is a worst scenario. So basically, this study is supported by Warren et al. Of 2022. They used a climate model, representative critical path 8.5 and 4.5, and it is predicted that the effect of climate change on crop production through influencing soils, water availability, and grain quality is quite inevitable. So the other aspect of this climate change is on livestock. We can see this bar graph over yields for different African regions and the countries. So it has a direct role in influencing livestock production and productivity in Africa. Especially the saddest news currently we are facing in Ethiopia. Around 1,000 part of Ethiopia and northern Kenya around Marsabit, this drought is really seriously influencing livestock production and the productivity. It is really directly the impact of the climate change. For example, Ethiopia in this 2022 lost really around 3 million livestock. So we have to get ready to tackle this climate change. That's why we have really developed such kind of training through Reform. So we have to appreciate the initiative that Reform has taken. If we see the other aspects of climate change, we have now talked about the influence of climate change on agricultural productivity through food production. But the other side is agriculture itself, the agricultural sector itself contributes to climate change through the global greenhouse gas emission. If we see this chart, the contribution of agriculture, forestry, and other land use systems to the emission of greenhouse gases in incurring climate change is not a simple issue. It's around 24%. It has 24% share as compared to electric supply, transportation, buildings, industry, and other energy services. We can directly get this information from the World Bank Group report of 2020. So the contribution of the agricultural sectors through generation of methane, carbon dioxide, and nitrous oxide is of tantamount. So we have to also see both sides, the effect of climate change on agricultural sector and the contribution of the agricultural sector on climate change has to be clearly seen. The interplay between these two issues has to lead us into the tackling of this evil in order to produce grain through maintaining our soils. So if we see the regional comparison of agricultural greenhouse gas emission for East Asia and the Pacific, Europe and Central Asia, Latin America and the Caribbean, Middle East and Northern Africa, North America, Southeast Asia and Sub-Saharan Africa, and the world, really agriculture has a great role through animal production, which leads to production of methane, and through fertilizer application into agricultural fields, especially in commercial agriculture, where judicious amount of fertilizer will be supplied to fields to support the normal physiological activity of the crops. So through these agricultural practices, greenhouse gases were emitted and contributing to the climate change. We can also see this information from the World Bank of 2020. So if we see the other aspects of agricultural production, really it's sad news. From agricultural production, from field to mouth, we'll be losing from 25 to 30% total food production. This figure is not an easy number. We have said we have almost closer to 850 million people who are suffering from food shortage and economic empowerment. Here we are losing almost closer to 30% of food production. Through this wastage, they also incur 8 to 10% of greenhouse gas emission, which is directly contributing to climate change. So we have to think also here, in order to preserve our food through post-harvest loss management. This graph also shows the trends of food wastage and the contribution to the climate change through emission of carbon dioxide and methane and nitrous oxide through different world regions, starting from Eastern and South Pacific region to the Sub-Saharan Africa. And we can directly get this information also on Sustainability Journal, which was published in 2021. So we have to, as African researchers and agriculturalists, we have to work on how to reduce this food loss. So if this is the case, the critical question is how and to what extent agricultural production systems and food systems can contribute to climate change mitigation without compromisation of yield and the nutrition security has to be a priority area, for which we have developed this module to just give a bird's eye view of this case in order that African scientists can contribute their role. So here comes, what is climate smart agriculture and why it's needed? Climate smart agriculture, as we all know, is not a new concept or a new science. It's already there. But the technique, the approach, the way we do things has to be in a very smart way. Smartness is through integration of different approaches, techniques, and tactics, so as to secure and ensure food security under the change of the climate change. So basically, this climate change, as developed by the World FAO, Food and Agricultural Organization, of the 2010 meeting, it has 3 major pillars. Okay, the pillars of this climate smart agriculture are 3. The first one is increased productivity, enhancing resilience, and reduction of emission. So every aspect of climate smart agricultural practices has to contribute and enhance these pillars, the strengths of these pillars, or they has to reduce the impact of the climate change on productivity, resilience, and emission of these greenhouse gases. So we can clearly see how increasing productivity is manifesting. Simply, this is through production of improved nutrition and high tonnage of yield in field level, through improved management of water and soils. The resilience issue is about vulnerability, reduction of vulnerability through drought management and decreasing the climate-related risks for enhanced stress management. And the other one is the emission issue. So this is simply reducing the amount of carbon dioxide or methane production per kg of food produced or byproduct of food produced. So this also calls for climate smart soil nutrient and water management for better crop yield and economic development. So here we can see the nexus of application of different fertilizers, basically coming from mineral and organic inputs to enhance soil fertility, sustain crop physiology, and increasing yield. While we are applying these fertilizers, we are also directly increasing the production of carbon dioxide. So through climate smart agriculture, we have to manage the way our fertilizers are applied and organic inputs are introduced to our soil so that we can better manage our soil without influencing the biological, chemical, and physical property of the soil, and without contributing much amount of carbon dioxide to the atmosphere. So from this nexus, we can clearly understand that the contribution of agricultural inputs to the field is a production of greenhouse gas emission from the field to the atmosphere. So if we clearly understand this nexus, we can clearly manage the effect of this climate change through reducing the amount of gases released from agricultural crops so that our climate can be sustaining our livelihood. The other basic aspect of this climate change, it influences nutrient management and water management and influences vertical productivity of agricultural crops so that it can directly influence our feeding system and the contribution of agriculture to feed our population. So in this case, climate change directly influences the plant nutrition through the supply of nutrients and the water from the soil system and influencing the physiology of the plant, how they take nutrients from the soil, how the nutrient will be translocated from the soil, water and the minerals to the leaf, how photosynthesis operates, how the carbon and the water reacts through the photosynthesis and carbohydrate assimilation produced and retranslocated through phloem, how metabolism takes place. Different aspects of the physiology of the crop will be influenced, and that directly have an influence on grain yield production or food production or foliage production. So this climate change is really an issue that has to be managed through strategically planned and tactical approach. One of the approaches is through the application of fertilizers. We normally call them the 4 R's: right source, right rate, right time, and right placement. When we say, as clearly seen from the picture, right source is the source of the fertilizer, from where we bring this fertilizer, either from inorganic source or organic source. So if we identify the source, we have to manage the rate, be it the farmyard manure or nitrogen fertilizer or triple superphosphate or potash or whatever. We have to determine the rate based on the demand of the crop, either maize, cassava, yam, or whatever, or coffee. We have to know the nutrient demand of that particular crop and apply this nutrient at right time when the crop is physiologically active to pick those nutrients and function well through its photosynthetic processes. And the right placement also influences how these nutrients be absorbed and translocated to the plant system, so that the leftovers of these nutrients will not be contributing in the accumulation of carbon in the soil as a storage, and literally releasing this carbon and converting to carbon dioxide and contribute to this greenhouse gas emission. Is it clear, by the way?
Yeah, please.
Thank you.
We're on.
Yes.
Yeah, it's okay.
It's clear.
Good.
Thank you. Thank you very much.
Yes, it is clear.
Yeah. The other aspect that we have to see is the concepts, principles, and processes that should be followed in managing soil health. Yeah. In order to supply nutrients directly to crops and function properly through physiological processes, our soil has to be very healthy. When we say a healthy soil, it is a soil which is active biologically, chemically, and physically. Simply, the physico-chemical property as well as the biological property of the soil is active, means sufficient nutrients are there, moisture is there, microbial activity is there, enzyme activity is there. So the soil is healthy and productive, and that means it supports the normal growth and development of our crops or plants. So we have to worry for our soil healthiness, and we need to have a healthy soil, especially when we take African soils from west to east, from north to south. They have different properties. Some are affected by salinity, like West African regions. Some are affected by acidity, Central African soils, where high rainfall is there. Some are affected by drought. Some are affected by really heavy accumulation of aluminum and iron, which is contributing to acidity. So this climate change will be aggravating a healthy and a productive nature of our soils. That's why we have to work on our soils to support our agricultural production systems. Even this climate change is currently influencing the microbial population in the root zone, which have a tremendous amount of efforts through releasing enzymes and contribute in the decomposition process, so that nutrients will be released to soil and pumped through the root system into the plant. So this climate change has a tremendous effect. That's why we have picked this module to talk about and give due attention on soil organic matter management in African soils, especially in sub-Saharan Africa. So the other one, or the principles that should be followed for sustainable soil management are 6. I have just gone through literature. We have picked 6. The first one is we have to protection. Okay, we have to protect. This protection involves managing the physical, chemical, as well as biological property of our soil from degradation, either from biological degradation or chemical degradation or physical degradation. When we say biological degradation, it means simply the depletion of soil microfauna, where soil enzymes will be depleted so that chemical reaction in the root zone will not be functioning properly and the nutrient availability will be blocked. The other one is the chemical degradation. Simply, this means chemical property of the soil, especially the cation exchange capacity, percent base saturation, the anion exchange capacity will be distorted so that the chemical reactions that will be taking in the soil system will be not in a proper manner that directly influences nutrient availability, mobility, and uptake by the roots of the plant or the crop. The other one is the physical degradation. That means the loss of the physical characteristics like bulk density and particle density of the soil, which have a direct influence on water holding capacity and organic matter accumulation. So before this all deleterious effects comes, it's better to protect our soils through managing deforestation, soil organic management, and different strategies. The other one is restoration, to restore. This restoration is reclaiming degraded soil through the application of different strategies. One of the strategies are through the addition of soil organic matter, mulching, and compost to the soil. The other one is maintenance. We have to maintain our soil. That means boosting or booming the ecosystem service that we gain from our soil through water availability and quality. So management or maintenance, we have to maintain our soil. The other one is enhancement. Enhancing means simply to boost or productivity or bioactivity of the soil so that crop yield can be maximized and higher grain yield production can come. The other one is through development. So this is through extension of technologies from research universities to the farming community. And then this information can help our growers to just sustain their production at farm level. And the other one is through communication. We have to communicate research outputs, technologies, in relation to our soils and the water to our users. These are key 6 points that we have to focus on managing our soils on sustainable basis from year to year, from decade to decade, or from century to century. We have to, when we talk about soil fertility management and soil amelioration, we have to think a soil, because soil formation is very tough. Even it's very difficult to attain or to gain a millimeter of soil thickness within even 100 years. So we have to take care of our tropical soils. The other aspect that we see today is the nature of the healthy soils, or the typical properties of healthy soils. They are 9. The first one is sufficient supply of nutrients. A healthy soil is a soil which is capable of supplying nutrients on a very sufficient manner that can contribute for normal growth and development of the crop or the plant, so that the normal physiological process of the plant can be active, and then we can get a healthy yield or a healthy produce. Okay. The other one is the tills. Okay. When tills come, simply our soil should not be very compact enough. That means if the soil tills is very poor, root development is very inferior, so that the feeder roots cannot easily pump water and the nutrient from the soil system. Then the growth and the development of those plants or crops will be influenced. So our healthy soil is a soil which has a good or a very good soil tills. The other one is the depth, sufficient depth, especially this is a rhizosphere issue. Okay, the soil has to be very deep enough so that root growth, formation, and development and nutrient mobility will be very conducive. So one of the typical characteristics of healthy soil is depth. Okay, the other one is drainage system, good internal drainage. Okay, drainage, it has to be well drained. It should not be affected by waterlogged. When it is affected by waterlogged, both the macro and the micro pore spaces will be contained by water, so that oxygen mobility will be influenced. When the oxygen supply in the soil system is decreasing, the reaction will be anaerobic. The process is called physiologically asphyxiation. So it leads to sulfuric acid formation, which one side increases soil acidity through sulfuric acid production. In another side, it halts nutrient mobility, and soil temperature will be very chilly, so that the root system will not be advancing and crop production will be influenced. The other one is the population of microorganisms in the soil. A healthy soil has to have a judicious amount of parasites or microorganisms in the soil, like actinomycetes, bacteria, fungi, which directly contribute to enzyme production that have an influence on organic matter decomposition and the nutrient mobility and the pH regulation. So a healthy soil has to have a good amount of soil microfauna. That's very important. The other one is a healthy soil has to have a good amount of plant growth promoting organisms like bacteria. Bacteria are very important in this aspect. Even currently, through different formulation, these PGR or plant growth regulating bacteria are introduced in different countries, and they are now commercialized even. And naturally, in the soil, healthy soil has to have these organisms. The other aspect is a healthy soil has to have a low weed pressure. The soil seed bank of different parasitic weeds like striga, like mistletoe, like cuscuta, like parthenium, like orobanche, like digitaria, these very aggressive and highly competitive tropical weeds should not be in a sufficient number in the soil. Okay, a healthy soil should not have normally a well accumulated soil seed bank of very dangerous weeds like striga, which is very problematic in tropical Africa, like Sudan, Ethiopia, Kenya, in Chad, even including the tropical soils of Somali, Eritrea, and then down to the South Africa. It almost really influencing 500 million hectares of African soils. So a healthy soil should not support such dangerous parasitic weeds in its system. The other one is pollutant should not be there, or if there, it should be in a very minimum amount. The soil by itself can reclaim or can cure itself. So the amount of chemicals, harmful chemicals.
Boa tarde, colegas. Aqui chamo-me Arthur Inácio Fernando.
Please, would you mind muting, please? Okay, harmful chemicals should not be there. And the other one is it should be very resistant to degradation. A healthy soil has a good physicochemical as well as biological property, so it cannot be easily degraded. Or, for example, it cannot be taken by runoff through water or through wind erosion, like northern and western African countries, where wind erosion is also equally important as soil erosion in Central Africa, Eastern Africa, and South Africa regions is of prominence. The other one, it has to be very resilient. Okay, a healthy soil are soils that can easily invigorate themselves and can support a healthy plant growth and the development so that producers or agriculturalists like us can have a good amount of harvest or yield. So these are the typical properties of healthy soil. So climate change directly influences or have an impact on these properties of the soil. So we have to be very careful in handling these issues, right? So if we see the effect of climate change on the production of these greenhouse gases, especially carbon dioxide, methane, and nitrous oxide. This is a century from 1750 to almost 2018, several years of data. It implies that the amount of carbon dioxide produced, the amount of methane produced, and the amount of nitrous oxide produced in part per million and part per billion is indicated through this graph. It's really very fascinating that from 1715, where lower amount of carbon dioxide, methane, and nitrous oxide is there, we can see how it has advanced into really billions of part per billion, which means directly influencing the ozone gun, the O3, and increasing the global temperature or influencing the atmospheric temperature. So this issue should not be seen very serious. We have to see these issues very seriously. As this trend shows, if this continues like this, the global temperature will be increasing by 2 degrees Celsius. It means if this currently existing, especially African temperature, is increasing more than 1.5 degrees Celsius, we will completely losing our crops because it directly blocks enzyme activity and metabolic activity, any chemical reaction, water availability. So we have to act. The message that this graph tells us is simply, we should not keep silent. We have to work aggressively to reverse this discourse so that our agriculture will not be influenced and our grain production will not be impacted. So we'll be having normal harvest and supply to our population a healthy food. If we don't act properly, really we'll be losing a lot of things. And we can read this information further from Mendel 2020. It's published in 2021. So sufficient information can be observed from this article. The other aspect of the influence of climate change on our soils is through 4 aspects. First, the temperature will be rising. Heavy and intensive rainfall will be coming in some parts of the world or in Africa. In some parts, the rainfall will be declining. And finally, it contributes to the booming of carbon dioxide concentration. For example, if temperature will be rising, what will be happening? The effect of the front one shows the effects: soil salinization, loss of organic matter, soil compactness, reduction in CEC. CEC means cation exchange capacity will be declining, reduction of soil fertility, soil structure, vulnerability to soil erosion, poorer water holding capacity or retention capacity, reduction of soil organic carbon, production of high amount of volatile ammonia, and the declining of enzymes will be emanating, and bioavailability of nitrogen and phosphorus will be declining. What does this mean? This means directly influencing crop production. Okay, if the global temperature will be rising, it directly influences the global crop production or plant production or global food supply, global economic growth. When we come to our African continent, because we are totally in tropics, it means a lot. It means a lot. So we have to be very careful. Different universities in different African regions has to take this as a note and contribute in tackling this very evil process. The other deleterious effect of this climate change on our soils is through intensive rainfall. By the way, this climate change is like economic booming. The haves will be more having and the lesser one will be poorer. So Central Africa will be having a lot of rainfall. As climate prediction shows, part of Eastern and Horn Africa will be drier. In the highly rainful regions, destruction of soil aggregates, risk of soil erosion, leaching of basic cations, soil acidification, reduction in cation exchange capacity of our soils, lot of nutrient supply, especially nitrogen, development of toxic chemicals like iron, manganese, aluminum, and boron accumulation, and the loss of nitrogen through denitrification will be inevitable. What does this mean for crop production? As the first one, this heavy rainfall also leads to loss of the most fertile part of the soil, influencing chemical property of the soil, harming the physical property of the soil, and degenerating the biological property of the soil. If this degeneration is there, it means nutrients availability and supply will be very poorer, so that nutrient supply to our crops will not be available. Due to this, we'll be facing really crop production in a very tremendous manner. So the other aspect is the opposite of this one, where rainfall will be decreasing, soil salinity will be manifested, moisture deficit will be very prominent, drought will be very famous, loss of nutrient from the root zones is also there, and nitrogen fixation by legumes will be also there, okay? Because enzyme activity will be halted, so biological nitrogen fixation will not be available. So this one is also direct. It has also direct influence on crop production and the nutrient supply and grain production for sustaining our population and our economic growth. The other one is increment of carbon dioxide, which directly increases soil carbon availability in the soil. So our soil will be storing carbon, which is very dangerous, because later it will be leading to carbon dioxide production and releasing to the atmosphere. The other one is bioactivity of microorganisms will be increasing for quite some time, and after any period of time, this activity will be blocked, so the soil will be very dry. And the other one, it increases a fungal population. This fungal population, this fungi will be very dangerous for crop production because they lead to disease, especially soil-borne diseases in tropical soils. Food production, sugarcane, cotton, maize will be influenced because of this. So this climate change has really multi-faceted effects on our soils. So we have to better act through teaching, training, research in such manner. So our university will be contributing to this. The other, now we have talked about the background and the situation, the influence of this climate change on our soils, how we can manage our soils. So the influence of climate change on our soils. And the next point will be the relationship between the soil and the water. Okay, the soil itself is not sufficient. Managing soil only is not sufficient for crop production. So there has to be a linkage with water. So when this comes, three aspects of water will be appearing. The first one, as you know, I hope most of you are from crop science, soil science, natural resource, or environmental science expertise. So in this case, we can easily understand the forms of water available in the soil, like hygroscopic water, capillary water, and gravitational water. So soil mechanics, soil physics, soil chemistry, soil biology, ecology, and hydrology can act here. So when we say hygroscopic water, this is the water which is not available to the roots of the plant because the amount of water present in the soil will be very adhered to the crystals of the soil particles, and is very tough for root of the crop to pump this water. They will be exerting a lot of energy. A lot of kilopascal energy or kilocalorie energy will be exerted to pump this water. That will be reversing the net energy production or ATP production in the plant system. This is a direct crop physiology. So this water is really has no importance from agricultural point of view. Because this water leads to wilting, especially permanent wilting, where completely the physiology of the crop will be collapsed, leading to degeneration of cells and enzymes. Any biochemical reaction will not be taking place when this is manifesting. So either we have to irrigate it, or we have to supply water in a sufficient form. If there is rainfall, it's okay. If there is no rainfall, we have to supply through irrigation or through other means. The other one is the capillary water, water that can be pumped through a capillary rise from the roots, from the root system, from the root zone, from the rhizosphere. And this water is very available until the point of field capacity. But if this water is beyond the feed capacity, it will be converted to gravitational water, where all the micro and the macro pore spaces will be occupied by water molecules. That helps, as our former said, oxygen mobility and carbon dioxide exchange in the soil system, which directly influences the metabolic activity of the root zone and the microorganisms in the soil system. So we have to be very careful in managing this. So the soil, the water, the plant are interconnected. So if we see this directly to plant growth and the development from this figure, nutrient management will be really very tough in the presence of such deleterious effects. So in this case, water plays a lot of role. Almost 90% of the plant is fresh or succulent. It's water. It's source of oxygen and hydrogen for photosynthesis or for carbohydrate synthesis. It's very much important for transpiration. Transpiration, as you know from crop physiology or plant physiology, it's a necessary evil process. It is very necessary, as well as a very evil process. It is necessary because through this transpiration, water and the mineral will be transported through transpirational pool to different parts of the plant, and photosynthesis take place. It is an evil because judicious amount of water will be lost from the soil system. So it is a necessary evil. As I hope we can understand this easily. So the other one is synthesis of carbohydrates, especially through photosynthesis, will be influenced. And then we have to be very careful in this aspect. So the plant-soil relationship, as well as the water, can be really connected or interconnected through a term called soil-plant atmosphere continuum, or SPAC. This is very essential from crop physiology point of view. If we not clearly understand the soil, plant, and atmosphere relationship, crop production boosting through genetic improvement, for example, through breeding, through physiological, setting physiological experiments, fertilizer experiments, water requirement experiments, or any type of research on soil, plant will not be very successful. So as African scientists, we have to clearly understand the interconnectedness of the soil, the plant, and the atmosphere clearly, and understand the crop water demand and the crop nutrient demand, and set an experiment and recommend proper recommendation. So climate change, when we bring the influence of climate change, it distorts the smooth flow or interconnectedness of soil, plant, and atmosphere through increasing temperature, through increasing carbon dioxide, through shortage of oxygen, through shortage of nutrient mobility, through shortage of water in different aspects. So we have to manage this in a very productive manner. So as African scientists, we have to clearly understand the influence of climate change in distorting the interconnectedness of soil, plant, and the atmosphere. Okay. So this can be clearly manifested through this diagram or figure. When we see this figure shows us the water movement in the soil system, to the plant system, and to the atmosphere. And this is not through really a free, it's not like a free lunch. A lot of energy expenditure is here. A lot of energy will be really expended, and then a lot of ATP will be lost. The energy can be measured by Pascal or kilopascal through pressure deficit. So the first picture A shows when water is moving from the soil system, from the root zone to the plant system, and the water is leaving the plant system to the atmosphere. This is a normal pathway. This is simply we call a transpirational pool. Okay. In the second one, in the B, when water is entering into the plant system through both ways, from the soil to the plant system, and from the atmosphere into the plant system. Okay. So as crop scientists or as soil scientists or hydrologists or crop physiologists, we have to typically understand the type of crop on which we are working and its physiology to set an experiment and give a good recommendation. The third one is C. It is a system whereby water is coming rather from the atmosphere, okay, in calm plants, basically in desert plants, and channeled into the root system. So this is a typical water movement through the plant system. So climate change typically really distorts these pathways and influences the way water will be retained in the soil, in the plant system, and that water be productive. When I say productive water, a water that can be just converted to carbohydrate or glucose. And finally, through metabolism, converted to ATP, and then maybe in the form of grain or food or like cabbage in the form of leaves. So we have to clearly understand this. By the way, are you following me? Am I okay?
Yes, you are.
Thank you
We
very
are following.
Thank you very much.
Yeah, sure, we are following.
We are following.
Thank you. Yeah, thank you very much. Now the next point is the challenge of climate change to soils and soil fertility management. Okay. Not only climate change influences crop physiology and soil's physical, biological, and physical properties, it also influences the way we manage our soil fertility status at field and landscape level. Okay. This climate change can affect soils, okay, through incurring erosion, halting nutrient mobility, increasing soil alkalinity and acidity, decreasing concentration of carbon in the soil, limiting pumping of or channeling of nitrogen, the phosphorus from the soil, and simply it influences the terrestrial ecology or terrestrial ecosystem so that normal growth and development of the plants will be influenced. The other aspect is climate change puts soil under pressure through really increasing soil temperature, through decreasing decomposition, mineralization, organic matter accumulation in the soil, especially formation of humic acid, and declining the nutrient content of that soil. For example, one aspect of climate change on soils influence is in peatlands. They will dry out. Then the organic matter can quickly break down. then they release carbon dioxide into the atmosphere. So the concentration of carbon dioxide will be increasing, and it means directly contributing to the raising of temperature or shrinking of the ozone. Okay, so we have to very much aware of this scenario. If we see really the relationship between soil organic matter, soil carbon or soil organic carbon storage in kilogram per meter square, and the mean annual temperature, this is a research adapted from Tan et al. Of 2020, you can clearly see the regression equation. Okay, as soil organic matter storage increases in the soil temperature will be decreasing. Reversely, as mean temperature is increasing, soil organic matter storage in the soil system is decreasing. Why soil organic carbon decreases as temperature increases? Because for a short run, increasing temperature leads to enzymatic activity in the soil system, especially in the rhizosphere. So the already existing organic matter or organic carbon in that system will be fastly decomposed by actinomycetes, bacteria, or fungi. Then, after quite a period of time, this stored stock of carbon will be shrinking. Then, as temperature advances, it will be leading to almost zero supply of organic matter or organic carbon to the soil system. From research perspective, the coefficient of determination, R square, means the coefficient of determination, it is 0.5, means 54%. It is a very huge number for soils, for crop physiology, okay? So if we see an experiment conducted on such issues, this figure can vary from different regions of Africa to another one, but the evidence shows that when soil mean annual temperature is increasing, the carbon stock in the soil system will be declining at plot level, at landscape level, at regional level. So we have to work on reaching, to tackle this, we have to work on supply of organic matter to the soil. So the other one is the effect of climate change on our soils is through really soil fertility loss, through flooding. We can see this picture from this figure, how soil fertility is influenced by runoff. Okay, the kinetic energy emanating from the runoff, detaching the most productive soil part, which is leading to really loss of top most fertile soil, like loss of nitrogen, like loss of the carbon microorganism population in the soil, accumulation of organic matter in the soil, destroying or destruction of the physical structure of the soil when soil mechanics, okay? It's the mechanical and as well as kinetic energy exerted on this raindrop, so mechanical runoff through kinetics or kinetic energy. So really, this is a very tough case. So we have to very careful in maintaining the forest or vegetation cover of our landscape. For example, in Africa currently, in different parts of Africa, from east to west, from north to south, Central Africa basically is a Congo forest, like Brazilians. Really, we are destroying our forests. Okay, this deforestation is directly means not only loss of the trees, but also it is a loss of the most top fertile part of our soils, which has a direct impact on crop production, dam, irrigation, water supply, and a lot. It's a lot, okay? So we have to be very careful and give due attention in managing our land cover through forest management, through tree planting. Especially nowadays in Ethiopia, we have a good experience. The Prime Minister took an initiative to plant billions of seedlings. Kenya has also took this experience. So we have to expand this, okay? We have to expand this. The other one is the influence is through carbon dioxide increment. when carbon dioxide will be increasing the atmosphere, simply directly influencing the ozone layer. So the ozone shrinks and the temperature will be rising in the atmosphere. So it leads directly to organic matter decomposition and water availability for plants and microorganisms. The other one is through temperature, high temperature, okay? High temperature, I said, enzymatic activity will be blocked, soil mineralization, decomposition will be affected. So proper supply of nutrient to the crops or the plant will be implanted. The other one is through variation of the intensity of rainfall, both in amount and the distribution. The pattern of rainfall will be distorted. It will be erratic. Maybe the onset will be earlier, and maybe it leaves off before the crops reach maturity. So we have to have a strategy how we can really cope up with such very delicious influence of the climate change. The other one is like flooding. Drought is the second one. Okay, drought. You can see this picture how the crop is suffering from drought. You can see how the soil surface is cracked. Okay, this is simply a moisture deficit. We can easily see how the physiology of the crops were shocked. It means simply yield loss, grain production loss, or food loss, okay, or economic loss. So climate change, like through flood, through drought, really is incurring a lot of losses. As I started my talk on just an hour ago, in this year, Ethiopia lost 3 million livestock because of this drought around Borno, southern Ethiopia. Really is very tough. Kenya has also suffered, is still suffering. And we have to work on soil management, water management, especially through water harvesting, irrigation supply, in order to cope up with this drought case. Maybe this meteorological drought, hydrological drought, okay, agricultural drought, or physiological drought. This case is both meteorological as well as physiological, even it is hydrological, because the hydrological cycle is already disrupted and there is no shower of rain, and you can see clearly how the crop growth and development is influenced. Well, the other management, so if this is the case, what shall we do? We have to manage our soils through different biological or physical practices. One of the biological practices is crop rotation, okay? We have to rotate, we have to follow patterns, sequences, we have to intercrop legumes with cereals, we have to add organic matter. The other one is we have to follow soil conservation practices, okay? This is a practice that we call climate smart, okay? We have to be very smart. Our smartness comes the way we integrate this crop, the way we rotate, the way we receive sequence, and the type of structures, soil physical structures we use for reducing water loss, okay, through water harvesting practices. This can increase water availability in fields. Literally, we call agricultural water harvesting if it's at field level. So Africa, as Africans, we have to really worry about our soils and the water to boost our grain production or food production. We can see the nexus of different practices like crop rotation, addition of intercropping, agroforestry, livestock, trees in their contribution to soil productivity, water harvesting or moisture retention, and increasing yield. We can really read this nexus from a journal called Land, published by MDPI. Such information is really quite available in such journals. And this simply shows us how different management practice for practices reduce production of nitrous oxide, methane, carbon dioxide, increase co-production through nutrient supply, water management, and leading to really restoration of water in the soil, reduction of carbon dioxide emission and the production of higher biomass, and fixation of nitrogen. Okay, when we say fixation of nitrogen, simply by using legumes, okay, like beans, like agroforestry tree species like acacia, like Malaysia, ferruginea, like Sesbania, like Leucaena. These are very important species. They fix nitrogen as well as they can be used as a fodder for our livestock. So cropping, agroforestry, and livestock contribute to the management of our soils. We can see here how leftovers of crop can be reincorporated. Okay, is a reduced tillage or zero tillage. This is a practice that can lead us to less destruction of the physical structure of the soil through either no tillage or minimum tillage. Okay, through supplying this as a mulch and incorporating to our soils, we can really tackle. Okay, this is one way of nutrient cycling. We have to recycle the nutrients we have back to our soil. This is it leads to relocating phosphorus, especially phosphorus, potassium, to the soil system. Okay, some are taken by the grain, and the remaining the stocks will be decomposed and re-channeled to the soil, so they can contribute in accumulation of organic matter to our soil, and later improves water holding capacity, nutrient supply. That then our crop will be really sustained well. The other one is through manure management or application of manure to our soils. This is a source of methane, manure, okay, where livestock is there. So if we can really properly use manure as an amendment strategy, it leads to the booming of soil structure, soil organic matter, mineralization, immobilization of nutrients through the soil system. So nutrient loss will be really optimized. So proper soil healthiness be managed, and our crops can easily get nutrients from this. It also ameliorates soil temperature through reducing evapotranspiration and evaporation. So this is also a very good practice. The other one is it helps to really hold microorganisms in the soil. Okay, since it has a carbon, microorganisms like actinomycetes, bacteria, and fungi do require this carbon as a starter, as an energy source. So they, after using this carbon, they can increase their bioactivity, which is directly responsible for microbial reaction in the soil system through enzymatic releasing. And so decomposition, nitrification process will be booming. So the soil fertility status of our soil will be increased. The other one is through application of fertilizer. Okay, this needs the 4 R's: right source, right application, right time, and placement. So through organic fertilizer application, we can also manage the fertility of our soils. Especially, we have to be very careful under commercial agriculture. Currently, we are adding a lot of fertilizer rates to the crops to boom crop production and the productivity, but this should not be at the expense of losing the biological, chemical, and physical property of our soil. Okay, it should be well researched, it should be site specific, and it should be also crop specific. Okay, we cannot apply in a blanket manner across roads or across landscape or regions when chemical fertilizers like nitrogen, phosphorus, potash, or boron, or these micronutrient rich fertilizers are on board. Especially, we have to be very careful while applying nitrogen, because it adds to generation of nitric acid. So we have to be very careful, because it depletes or it decreases soil pH and it booms to the soil acidification process. The other one is planting of legume crops, okay, through intercropping. This is a very well practiced approach in Africa, across Africa. These leguminouses are very useful in fixing nitrogen, atmospheric nitrogen, which is the most expensive one, through urea fertilizer, because urea is currently becoming very expensive for African farmers. So we have to resort ourselves in using these legume crops as a source of nitrogen and also as a source of protein. The other one is agroforestry. This part will be also dealt by another module. So agroforestry is one approach in managing soil and waters and tackling climate change. We can easily see from this picture how banana, coffee, and other tree species are growing together. The spice trees are also there. So simply growing on a small plot of land, different crop plants, and then increasing the productivity of our land per unit area. So the other one is different practices that can be or has to be followed for tackling this climate change. We call them climate smart agricultural practices like conservation agriculture, integrated nutrient management, agroforestry, water harvesting, and irrigation. Why they are smart? It's indicated in this table. The main components are also indicated, so we can easily understand by application of these practices, climate smart practices, so that we can tackle the effect of climate change on our agriculture and our economy. For today, I have used 1.5 hours. Thank you very much for your attention. The next couple of minutes will be allocated for some conversation, questions, comments, the suitability of the talk, okay? Thank you very much. Now the floor is open. David, back to you for collecting comments, questions, and suggestions for further evaluation of our module. Thank you very much.
Thank you very much for the presentation.
Yes, please. Thank you, Prof. Zelalem. I think usually what happens is we allow members to raise their hands, then you can just pick any of them to ask comments.
Thank you, David.
Yes. There's already somebody called Abdu who has raised his hand. Abdu Saud.
Abdu Saud, please welcome,
Yes.
please, Abdu.
Thank you very much, Dr. Zalim. And I'm Abdu from Egypt. I thank you for this good presentation and nice information in it. But we would like, if it's possible, to forward this presentation for our community to help us for, inshallah, to represent it for others for in the future workshop.
Thank you, Saud. Yeah, these slides and the whole module will be shared through forum to all African universities. Thank you for your comments.
Okay, thank you very much.
Jennifer? Jennifer, sorry.
Yeah, thank you very much. I appreciate very well the presentation, but I still missing some small details about some case studies. In Africa, we have different agricultural zones, and should be better maybe to have some kind of practices which should be adapted to the different zones. That was maybe a small gap. I didn't catch up about that one, but if you should have some kind of detail which can be adapted to the different zones, that can be more sustainable for the farmers, even for us scientists. Thank you very much.
Thank you very much. Your comments noted. Yeah, thank you. Mohammed, please. Mohammed.
Hello,
Hello,
Muhammad
Mohammed.
from,
Yeah, I'm hearing.
yes, I am
Yes.
from Sudan, University Khartoum. If possible, to make another by email list plus WhatsApp list, it is more access than email, if possible, to share this slide for us.
Okay. Thank you, Mohammed. Yeah. The forum will be taking care of its communication platform. Thank you for your comments. Okay. Onward, please.
Yeah.
Yes.
Dr. Zalim, can I ask?
Yeah.
I am Dr. Muhammad Abu Arab from Cairo.
Thank you. Please welcome.
Yeah. I think your lecture is under the umbrella of sustainable agriculture. So take into account zero tillage, the using of organic material as a fertilizers and other things which you can conserve our agriculture, and we can take into account the rainwater harvesting, how to make an irrigation water management to face the drought and the dry climate. This is, I think so, your lecture is this under the umbrella of sustainable agriculture.
Thank you. Thank you.
Thank you
Comments
for
well
your
taken.
presentation, and thank you for your good ideas we got it from your lecture.
Thank you, sir. Placid, please.
Yes, thank you, Professor, for a very wonderful presentation. My question is on soil microorganisms. You indicated that we need a very good amount of soil microfauna for a healthy soil for agriculture. And so I wanted to find out if there is a kit or a group of microorganisms that are indicators, key indicators for us to judge whether the soil has good microbial health or not.
Yeah. Thank you. Yeah. Basically, for the soil faunas, actinomycetes, bacteria, and fungi are there. In our module, we'll be including the specific ones which are highly linked to soil enzyme release and the degradation for soil organic matter. Thank you. Your comments well taken. Margaret?
Yeah, thank you, Prof, for that wonderful presentation. My name is Miss Inde Margaret from Chambogo University. Prof, I don't know, maybe in the subsequent presentations we cater for incorporation of gender aspects as we promote smart agriculture interventions in crop production, because I'm sure the kind of stakeholders we are likely to meet will be more interested in seeing the gender aspects integrated in our interventions. Thank you, Prof.
Thank you very much. Well noted. Your comments well noted. Okay. I don't see any hand, David.
Hello.
David.
Thanks very much.
Yeah.
Yes, I think there are still some hands, maybe some of them.
Yeah, Joshua, please.
Yes. Thank you. Yes, thank you. Thank you, Professor Zelalem, for the wonderful presentation. I'm concerned about nutrient management, particularly with the use of fertilizer applications by our farmers, particularly. This remains still a gray area, and the effectiveness of the use of fertilizer among our farmers still is underscored. What do you suggest can be done to ensure that we have effective use of fertilizer, particularly as it regards to the rate of application and when to apply and where it should be applied and the time of application? Thank you, Professor.
Yes, Prof. Zelalem, can we go ahead? Have we lost him? I think.
Hello, are you following me?
Yes, Prof. I think we had lost you, but welcome back.
Okay, yeah. For agricultural fertilizer recommendation, especially for crop nutrient recommendation, we have to set an experiment, okay, site-specific experiment or context-specific experiment or crop-specific experiment. For example, if it's a maize for Ethiopia or Kenya or Malawi or Nigeria, we have to first understand the nutrient content of that soil through soil analysis, chemical and physical analysis, and then undertake a preliminary test, and finally set an experiment and determine the appropriate nutrient requirement of that crop. Okay. Other one, Tabi?
Yes.
Please proceed.
Okay. I want to thank Professor Zalim and I want to thank also the organizer of this valuable workshop. Maybe I have two questions. You said rainfall and low rainfall, both of them have a negative impact. So how we can make balance to avoid soil deterioration? Also, can we use sewage water for agriculture production? What is their negative impact if we use sewage water?
Okay, thank you. The impact of lower and higher rainfall. Yeah, there are different strategies that can we follow when the rainfall deficit is coming. That simply we can use moisture conservation or agricultural water harvesting. If excess water is there in the field, we can use drainage to remove excess water from the soil, or we can use water laving like rice crops to produce crop. Regard to the sewage water, it depends. If it is contaminated with heavy metals, I personally say strictly no, because it has a deleterious effect on the physiology of the crop, the other in the food chain. It directly comes to human diet and affects us. So the water has to be tested. This sewage water has to be tested. If some deleterious chemicals are there, it has to be treated in oxidation boxes. Okay, thank you. Another, Joshua, are you there still?
Professor, I think you answered my question.
Yeah, thank you. Mohammed is, yeah, you raised your hand. So I don't see any new hand.
No, thank you. You already answered my question. Thank you. I'm Mohammed from. Thank you.
Thank you.
I have
Thank
my
you.
hands.
Zacharias. Yeah.
Zakaria, please welcome.
All right, thank you so much, Zelalem, for your nice talk. I am Professor Sisu from the University of Barako, Benin. So
Yeah, bonjour.
I heard from your lecture that climate change will really affect our agricultural production. So you listed a lot of solutions like management practices such as crops rotation. Can you hear me, please?
Yes, I'm hearing, yeah.
Okay, so you listed several solutions such as crops rotations, soil conservation practices, and so on. So from my understanding, our goal will be to just have a sustainable way to manage our, how to say, agricultural practices to just have best yields in the way to make resilient climate change effects. So from the list you give us, how can you help us in the choice, since we have different site conditions? So which solution will be better for each different condition? Do you have any material that can help to make that nice choice to help our farmers? So that's my concern about the talk today.
Yeah, thank you, Prof. Yeah, climate smart agricultural practices are site specific or context specific. Okay, different strategies are there for different countries or regions. I will be sharing the document for you. Thank you for your question and comments. Geoffrey, yeah.
Thank you, Prof, for the good presentation. Now, you say that fertilizer placement is very important as far as the sustainable soil nutrient management is concerned.
Yes.
But these days, it is common practice that farmers are applying foliar fertilizers. Whenever a crop has a problem, farmers apply foliar fertilizers. What's your view about applying foliar fertilizers? Thank you.
Yeah, thank you. Foliar fertilizers will be applied, especially liquid in the form of liquid. That's the process is called fertigation. Okay, especially for nitrogen. This is very important because nitrogen is a very delicate nutrient. It will be lost through denitrification, through leaching, through volatilization. In such type of cases, applying fertilizers in the form of solution helps directly the plant to directly absorb through the leaf and directly translocated for synthesis. Yeah, it depends on the type of fertilizer we use, especially for nitrogen fertilizers. It is applicable and valid. Thank you. Any hand?
Yes.
Yeah, Olanti. Please proceed. Hello.
Hello. I also raised my hand.
Yes, Sukati. Okay, BH Sukati, please.
Yes, thank you very much, Prof, for the very informative presentation. There is one part which I almost missed, the one on a graph where you presented some of the cases that are released. And unfortunately, they were expressed in different units, like in PPMs and CPPs. Will it be possible, Prof, to actually express them in one unit so that we can actually make sense of what is going on in that graph?
Okay. Thank you for your comment, Prof. Part per millia and part per billia. Yeah. The trend is the shifting of the concentration of carbon dioxide, methane, and nitrous oxide. In earlier years, it was in a very lower amount. We were measuring them even in part per millia. Nowadays, the concentration has increased and it is measured in part per billia. For the units, we can adjust and make uniform. Okay, thank you.
That would be fantastic. Thank you, Prof.
Thank you. Okay.
Yeah.
Yes. Olanti, please.
Yes, I Professor of Pastoral Agronomy and Forage Utilization.
Okay.
Federal University of Agriculture, Abeokuta, Nigeria.
Welcome, please.
Thank you. I want to thank Dr. Zelalem for the wonderful presentation. But there is an area that I would have wished him to talk about. All over Africa, I don't know whether it's so intense in other parts of Africa, but in Nigeria, we find that animals graze all over the place. And this grazing of uncontrolled grazing has a lot of effect on soil and litter accumulation. So this also has a way of aggravating the effect of climate change.
Yeah.
How do we marry this? I mean, in an attempt to find solution to this climate problem in agricultural productivity.
Yeah, thank you, Prof. Yeah, when the number of livestock is increasing, it leads to overgrazing. Overgrazing leads one to vegetation loss that incurs soil erosion. The other one is compaction, soil compaction.
Yes.
Particle aggregates will be influenced, so the water holding capacity of the soil, will
yes.
be increasing. The other one is methane gas. They contribute for the methane gas. So
Correct.
we have to manage the population of the livestock. Okay.
But you see, the issue. Sorry, the issue is that in most of African countries, the level of education of people that are involved in livestock production, because you know all these things on traditional practices.
Yeah.
The level of education and the level of awareness of farmers is so limited that nobody's controlling this. In other parts of the world, like in China, we know that even Chinese government have a way of paying off the farmers to reduce animal population. But nobody appears to have been conscious of this. No government, no African nation is probably doing this to consciously reduce the effect of animal impact on the soil, on the plant litter accumulation, and vis-a-vis humus development in the soil.
Yeah. So yeah,
I think Roof Forum has a role to play in this.
Yes. Through agricultural extension, yeah, systematic agricultural extension. Tabi, you are allowed.
Thank you very much. I am Dr. Tabi Kingsley from the Department of Crop Production, the College of Technology, University of Bamenda.
Welcome, please.
Yeah, my major worry is I want to first of all appreciate you for your presentation, but my worry is I think this issue, how can Reforum enable that these soil microorganisms that are very important, these endophytic bacteria, are made available? Because the problem to me, I think farmers are having is availability. A farmer might be interested in getting mycorrhiza, but where can we get them? So what is Reforum doing to ensure that availability, affordability, and accessibility of these important soil microbes is made available to our farmers? Thank you.
Yeah, thank you very much. Our experts and officers and the leaders like Dr. Florence and Prof. Majaliwa, David are hearing this question. So I'll forward your question to Reforum, and they will look into pathways through which we can really deliver this. Thank you.
Thank you.
Yeah.
Hello.
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 Catherine.
Hello.
Yes, Catherine. Thank you very much. My name is Dr. Gamau Catherine from Jomo Kenyatta University of Agriculture and Technology in Kenya. Thank you, Professor, thank you, Professor, for the good presentation. I appreciate the climate smart agriculture practices, very good for sustainability. But my concern, and I think a concern probably for many of us, is how we have talked about the food demand that has really increased. I don't know, shall we be able to meet the food demand with these practices, as much as they are good and good for sustainability? Shall we be able to meet the food demand? And then what is the place of modern technologies like precision agriculture in these climate smart agriculture practices? Because with the kind of food demand that we have, I don't know how we don't compromise sustainability, but again, we are able to meet the food demand because, like you have rightly put it, it is we are far from meeting this. Thank you, Prof.
Thank you, Dr. Catherine. Yeah, in order to supply the food demand of our nation, or especially for our Africa, it is quite inevitable that usage of improved technologies are a must. But this usage should not be at the expense of shocking our climate. For this, the one you indicated, precision agriculture, is one strategy where all the systems are well combine and synergize in a way that carbon dioxide emission, methane emission, and nitrous oxide emission are very low, where yield is maximum. One of the strategies of climate smart agriculture is to boost crop production at maximum level without causing a shrink or a negative effect on our climate. Thank you for your comments.
Hello? Hello?
Yes.
I am Nail, Suleiman Nail, University of Khartoum, Faculty of Agriculture.
Okay, please proceed, sir.
Yes, I am Suleiman Nail, University of Khartoum, Faculty of Agriculture, University of Khartoum. Thank you very much for good presentation, especially about the CSA. My question is, what are the impact of the climatic changes on chemical fertilization, especially that's applied by the local community or traditional farmers?
Yeah, thank you.
And the second question is, what's the impact of the climatic changes on evapotranspiration?
Yeah.
Because that's the main issue about the losing of water and drought, like that. Thank you very much.
Thank you, sir. Yeah, climate change directly has an influence on chemical fertilizer application, basically nitrogen, potassium, phosphorus fertilizers, because it has a direct influence on temperature. Yeah, if the temperature is higher, so volatilization like nitrogen fertilizer will be very high, and loss of these fertilizers will be at maximum. So it has a negative effect. It also boosts evapotranspiration. When the temperature is very high, water will be lost through transpirational pool at a very fast.
Thank you for very good answer for these questions.
Yes, Prof. Zelalem. I think we have lost him again. Let's give him like. Let's try to give him like a minute or so to see if he can log back in, because I see we still have some questions and comments from some of the participants. Yes,
Okay.
Prof.
Yes, please.
A Cosmas, I think Cosmas, you'd raise your hand.
Yes.
There's also someone called Emmanuel.
Yeah, please proceed.
Yeah,
Emmanuel.
thank you very much. Thank you very much. This is Cosmos from
Okay,
Uganda
Cosmos.
Martins University.
Okay,
Yeah,
thank you,
Prof,
sir.
thanks for your presentation. I have actually followed it right from the beginning to the end. Yeah, I just have a concern. There has been this growing trend of what we call agroecological principles. And then there is also climate smart agriculture. How different are these two concepts? Because sometimes you'll find what is known as climate smart agriculture is also being promoted under agroecological principles. Yeah, thank you very much.
Professor Majaliwa, you're also free to respond to that question.
Sorry, my connection is disturbing me.
Welcome back,
I haven't
Prof.
understood the last point. Sorry, I haven't got your question, sir.
Hey, Cosmas, are you able to rephrase?
Yes. Sorry, I think your network was
Yeah,
being
the
off
network is,
on. Yeah, so my concern is about agroecology. There's been a growing concern on the principles of agroecology to be incorporated in crop production or agricultural production. But then also when you look around, you see a number of NGOs and also researchers talking about climate smart agriculture. So at times you come and you find out you can't get a clear difference between climate smart agriculture and then also the agroecological principles, because some of these things are cross-cutting. So I don't know, in your own opinion, what do you think the difference between those two concepts? Thank you very much.
Thank you very much. For your information, currently we have a climate smart agriculture training at MSc and PhD level funded by the World Bank. We have seen the gap of this, and last Friday we have launched this agroecology at MSc level for the first time in Ethiopia. Yeah, agroecological principles are, some of them are principles of the climate smart agriculture. There is an overlap, and to my understanding, climate smart agriculture is a domain of agroecological principles or agroecology. So I can read further on this, and you can also, and we can integrate this information. For information, we have this climate smart agriculture and biodiversity conservation at MSc and PhD level. And we have also launched this agroecology because we have clearly seen these climate smart agricultural practices are not directly feeding this, and that's why we picked this agroecology as a discipline. Thank you. Yeah, David, there is a noise. Adam.
Francis,
hello.
could you please
Adam,
mute that?
Hello, I'm Adam
hello,
Bosch.
Adam, I'm hearing you. Adam Bosch, please.
Okay, I am Adam Bosch. Adam from Sudan, Assalam University. I'm associate professor in water management. A great challenge for the agricultural sector is to produce more food under water scarcity conditions, especially in arid and semi-arid regions. So it is time to catch each drop of water. Please, Professor, can you tell me about how can smart agriculture can promote or strengthen the water productivity? Thank you.
Thank you, Adam, for your question. We will be having a presentation on water management, climate smart water management, subsequent days. I have noted your question. Thank you.
Thank you. Okay.
Yeah. Abdu.
Yes.
Please proceed.
Yes, I'm sorry. I come back because I asked a question before, but I have a very important question. Is it allowed for me or not?
Please proceed, sir.
Okay. Dr. Zalim, you mentioned the strategy to manage soil fertility through the climate smart agriculture is to select the correct type of fertilizer and add the correct amount and in correct times. By using all these correct things, I think it is impossible to make it as correct as possible if we use a traditional method. Therefore, I think we need more advanced method, like what's called precision agriculture.
Yeah.
So my question is, what is the role of precision agriculture to achieve these goals for soil fertility management? And the second question is it what is the economy of if to apply such techniques or technology to achieve the goal of the soil fertility management in the smart climate agriculture? Thank you.
Yeah, thank you very much, sir. Yeah, precision agriculture is an agricultural practice whereby proper nutrients demanded by the crop be applied. Okay, it's a very technical, highly technical and highly capital intensive.
That's right.
Yeah, for our African farmers, the likelihood of this application is very minimum, but for commercial farmers, okay, like high value crops like grape, like vegetables, high value crops like vegetables with high level of investment, yeah, we can apply this. So even we have to shift our agriculture from traditional one to commercial and highly productive type through the make use of precision agriculture. This precision agriculture is the one which is contributing to really reduction of carbon dioxide and methane, this greenhouse gas emission. So
yes,
we have to advance this technology in Africa. That's my comment.
Okay, thank you.
Thank you, sir. I don't see any new hand. Adam is done. Sukati.
There is a hand, yes.
Prof, I had a hand.
Sukati, yes, welcome again, back.
Okay, thanks. Thank you very much, Prof. Actually, in the presentation, there was a little bit some touch on the crop physiology. Prof, what can you say about the types of crops that can actually help us fight this climate change? Any comment on that? And the role maybe plant breeding can play?
Yes. Yeah. To tackle this climate change, we have to a little bit shift from C3 plants to C4 plants. When I say C4 plants, these tropical plants like sorghum, maize. Okay, these are they can easily fix carbon dioxide with a very cheaper energy expenditure. So we have to adjust our production systems, or we have to gear our production systems toward this C4 plants rather than focusing on C3 plants like wheat, barley, and potato. These are C3 plants which demand higher energy currency. Okay. The other one is we have to follow stress physiology. We have to undertake breeding strategy or breeding for biotic stress management. Okay, through breeding, we can improve the genetic background of the crop and develop a variety that can fit to the existing climate. And the future of our breeding strategy has to be also on this stress physiology. Okay, whether it is salinity, fertility, high temperature, higher level of carbon dioxide, it's the way forward. I suggest stress physiology or breeding for stress as a strategy for coping up with this climate change in Africa. Yeah, breeding is one strategy. Thank you, sir.
Hello.
Yes,
thank you.
Yeah, please, I want to ask Dr. Zelalem if there is any need for advocacy in the whole. Because there are, like I mentioned the other time, there are so many practices in African agriculture that are not quite in tandem with the whole principles, and that cannot enhance the achievement of the goal of climate smart agriculture. For instance, in many parts of Africa, people still burn the bush to establish farm and so on and so forth. We know the effect of burning both on the soil and on the environment.
Yeah.
Yeah. The other time too, I mentioned about indiscriminate grazing all over the place that also has zone effect on the soil and so on. So, but these ones are not just going to be solved by carrying out research alone. There must be some level of advocacy to be able to achieve the laudable goals of climate change agriculture, for our people to change the orientation of our people. So what role do you think that the advocacy will have in this whole concept of climate change, climate smart agriculture?
Yeah, thank you, sir. As Dr. Florence and Prof. Majaliwa indicated earlier, there is a module which will be taking care of this advocacy issues through policy. So let us wait for that.
Okay. All right. Thank you.
Thank you, sir. Yeah. Emmanuel.
Yeah. Good afternoon.
Good afternoon, sir.
I am Emmanuel from Mozambique, Edward Mondlane University. So, according to your presentation, one of the aspects threatening the environment or worsening the climate change is the grazing, like livestock, because they release methane, they trample the vegetation and so on. So, but in the strategies that I saw in the presentation of climate smart agriculture, the strategies only focus on crop production side. And I think it's in most websites or materials that I find related to resilient agriculture, they all focus on the crop itself. But we know that agriculture is not only the crop side. We also have livestock, we also have forest within agriculture. We also have fisheries. So how are we gonna go all these other sectors that are part of agriculture in terms of trying to minimize the impacts of agriculture on climate? Thank you.
Yeah, thank you, Emmanuel, for your comments. There is also a module which is under development already. To my knowledge, it's already almost completed, which gives due attention on the livestock issue, on the forestry issue, like through agroforestry by Prof. Ashil. And then this issue will be handled by another module there. But I brought this information just to see the influence of climate change on our livestock production and the influence of livestock on soil degradation through vegetation removal, compaction, and contribution of methane gas. Otherwise, it will be treated in the future with another module. Yeah. Okori.
Thank you.
Please welcome.
Thank you.
Please proceed.
Yes, Prof. Maybe we can give another 5 minutes and then we close. I think it's already 5 p.m. East African time. Yes, so I think if there's you can allow one or two. Yes,
my driver is calling for me. It's time to leave now the office. Would you wind up, please, David?
Yes, I think maybe the members can reserve the questions since we are here again tomorrow.
Yes,
we can highlight some of the questions we have not, comments that we have not addressed, and maybe also throughout the week we are going to continue interacting.
Yeah.
So I think in the next 3 days we shall get a bit more feedback from the members. So maybe I beg we close. I've requested participants to kindly register for today's attendance. I know I shared the list a bit late, but I think as we are here, I've put it on chat. We shall also be providing certificates after the training. So I think it's important that you all participate until the end.
Thank you very much, David.
All right, thank you. I think let's wish everyone a nice evening, and we'll meet again tomorrow at the same time.
Yeah, thank you all for your attention and comments.
Okay, thank you so much.
Thank you very much.
Thank you.
Thank you.
God bless you all. Thank you very much.
Thank you.
Thank you so much.
Thank you, Prof.
Meet again.